So dear children, in previous classes we have seen about different type of isomerism with the example. Today let us see some fundamental concept in organic reaction mechanism. Usually in an organic reaction, the reactant or some organic molecules react with an appropriate attacking agent. This reaction leads to the formation of one or more intermediate and final products are formed. Okay, so in the organic reaction directly the products sometime only we may get, otherwise we will get with a different mechanism. So the sequence of the organic reaction is reactants plus attacking reagent. That means it need not to get any other substance to combine with that. That reactants itself will undergo certain changes with the help of some of the agents. That is known as attacking agent. So when reactant is combined with attacking agent, intermediate products will form. So the intermediate products, once again it undergo changes and changes a products and byproducts. In this, a substrate, what do you mean by substrate? Substrate is that reactant on which attention is focused. It supplies carbon for the formation of new bond in product molecule. A covalent bond between two carbon atoms is broken in the substrate during an organic reaction. So in the molecule, the bond cleavage occur. So that is known as reaction substrate. So in a mechanism of organic reaction mechanism is a sequential account on each step. It contains different step. In that first one, it shows description of detail of electron movement. Next, it gives energetics during bond cleavage and bond formation. What type of energy involved during bond cleavage and bond formation? That also will be involved in reaction mechanism. And the rates of transformation of reactants into products. What is the rate of the reactions? The reactants will change into product. During that, how much time it takes, that shows rate of reactants, kinetics. And in this reaction mechanism, we will get the information about understanding the reactivity of the organic compound, and also it helps in planning strategy for their synthesis. So this is the usage of reaction mechanism. So all the organic reactions involve such type of mechanisms. So in this mechanism, where certain terms will be used. Fission of covalent bond. What do you mean by fission? Fission means in the name itself it is there broken. So a covalent bond between two atoms of given compound may be broken into different compounds. So during that time, nature of the given organic compound, the nature of the attacking reagent and the reaction condition, this all involved during fission. So fission of covalent bond leads to generation of intermediate organic species. So this can be detected by spectroscopic method. We cannot see, and this intermediate will be short-lived. Immediately it changes into other product. Another one, in this fission, there are two type of fissions, that is homolytic fission and heterolytic fission. Homolytic fission, what do you mean by homolytic fission? It means breaking a covalent bond in such a way that each atom separates with one electron of the shared pair. In a homolytic fission, breaking of a covalent bond in such a way that each atom separate with one electron of the shared pair. So if it is separating, both will get one electron. So in this type of bond, fission takes place between two similar atoms having similar attraction for the shared pair electrons. So if the electrons are there, You know that covalent bond is formed by sharing of electrons. So both atoms will have attract on the particular electron. So here in this homolytic fission, each atom will have same type of attracting on this particular electron, so that they will have one electron each. So homolytic fission leads to the formation of highly reactive neutral particle containing unpaired electron. So because of homolytic fission, unpaired electrons are formed. So such unpaired electrons are known as free radicals. The new term, it is free radical. So when two compounds are there, two compound or a compound, what happened to the organic compound? Bond broken, and each atom will have unpaired electrons. Such type of species is called free radicals. Such type of free species is called free radicals. So here the example they have given is CH3Br. CH3Br, it undergoes cleavage and you will get CH3 free radical and bromine free radical. So in heterolytic fission, breaking of bond in such a way that both electrons of the shared pair are carried away by one of the atom. So when two atoms are there in a molecule, only one atom carry the pair electron, resulting the formation of cation and anion. So due to that, in a compound which gain that electron, that will change into anion, which leaves the electron, that change into cation. So this type of bond fission takes place between two atoms widely different electronegativities. That means when two atoms are there, one will be higher electronegativity. So that what happen, it take this electron towards with it. That is known as heterolytic fission. For example, one compound is there, it undergoes electrolytic fission, means one substance will take the both electron and another substance will leave the two electrons. So in such a way, electronegativity of one element will be more than this other element. Here the example which I given is, by seeing this example you can understand this. So order of carbocation stability. Such type of compound is known as carbocation. So when due to heterolytic fission, some anion and cations are formed. So in this electronegativity of certain element X, which will be anion, that will change into more electronegativity, and which is giving an electron, that will have less electronegativity. So quite often the cations and anions are formed by heterolytic fission or carbon based and are respectively known as carbocations and carbon anions. Carbocations and carbon anions. So carbocation also known as carbonium ion. Carbonium ion. So what we have seen, so due to the reaction mechanism, intermediate species will formed. So in the intermediate species will undergo cleavage. The cleavage is known as fission. In this fission, homolytic fission is there, heterolytic fission is there. In a homolytic fission, free radicals are formed. Free radicals means each atom will get one electron. So in a heterolytic fission, carbocation or carboanion forms. So it is formed due to one element will gain two electrons. One unpaired electrons will be gained by one element. So that change into carboanion and carbocations. So carbenes another one intermediate. It is formed due to photolysis. So you have learned few of this hybridization in this before lessons. In this you can understand the type of shape of the orbitals. According to this shape of the orbitals, it will have intermediate. For example, if this sp2 hybridization, if it is sp2 hybridization, it will have the free radical. The intermediate will be the free radical. intermediate will be the free radical. If it is sp3 hybridization, the shape is pyramidal and the intermediate will be the free radical. And if it is sp2 hybridization, it is a trigonal planar and that intermediate will be carbocation or carbonium ion. If you see the stability, you know the tertiary and secondary and primary substance will be there. Tertiary will be more stability than secondary than primary. So triplet carbene, carbene is one of the intermediate which is formed due to the formation of photolysis reaction. So in this singlet carbene also there, triplet carbene also there. Triplet carbene will have the linear structure. So triplet carbene is more stable than singlet carbene. In a homolytic cleavage can also species in which carbon gets shared pair of electrons is called carbanion. In this CH3 is there, CH3 is combined, CH3 Z means Z is known as any one of the elements. So what happened this, when group Z attached to this carbon leaves without electron pair, this methyl anion is formed. So homolytic cleavage, this is the points on homolytic cleavage. A free radical is a species which have one or more unpaired electrons. What do you mean by free radical? Free radical is a species which has one or more unpaired electrons. It is paramagnetic. It can be detected by electron spin resonance spectroscopy. Electron spin resonance spectroscopy. So if you see the structure, some alkyl radicals have planar trigonal structure with carbon at the center, a triangle and 3 bonds directed toward the 3 corner. So of planar trigonal geometry. So you have sp2 hybridization and odd electron in p orbital above and below the plane of sigma bond. Sigma pi bond and all you can recall. Suppose if it can have one overlapping of height, overlapping of parallel side, sigma bond and pi bond. If double bond is there means one will be a pi bond, another one will be a sigma bond. Recall all those points. So in trigonal planar structure of alkyl radical, if you see this CH3 species, through this electron spectroscopy, alkyl symbol radical indicate the radicals have planar structure. In fact, optical activity lost when a free radical is generated and at an asymmetric carbon. So free radical will be generated due to the optical activity. So bipyramidal structure is another possibility when the central carbon undergoes sp3 hybridization and the odd electron is an sp3 hybrid orbital. Bridge head radicals are bipyramidal. If you take this example of CH3, the CH3 you will have sp2 hybridization. It's a pyramidal structure. It forms bridge head free radicals are pyramidal. So when you see the stability of free radical, this is important one. If you have allyl or benzyl ring, that will have more stability than tertiary and then secondary and then primary and then methyl group and vinyl group. So the stability of a free radical will be more in benzyl ring, then tertiary, then secondary and primary. CH4. Look at this example. From this you will come to know that which is having more stability. Next one, when you see this, when it undergoes different type of cleavages, it form because of this characters, electrons movement can be shown. So electrophile reagents or electrophiles are formed and nucleophile also formed. So electrophilic reagents or electrophiles are the positively charged and electron deficient compounds which have a tendency to form a bond by accepting an electron pair from another species. What do you mean by electrophilic reagents? These are the reagents. Electrophilic and nucleophilic, two reagents will be there in this mechanisms of organic. In this, electrophile is a positively charged or neutral species which is an electron deficient. For example, H3O plus Cl plus CH3NO2. What in this electrophilic reagents or electrophiles, these are the positive species. So in this positive species, electron deficient compounds which have tendency to form a bond by accepting an electron pair from another species. Example of positively charged species is NO2 plus, Br plus, Cl plus. So electron deficient atoms such as sulfur in SO3 or SOCl2. Nucleophilic reagents. Nucleophiles or nucleophilic reagents are anions and molecules with unshared pair of electrons. They have a tendency to donate a pair of electrons to another species. Example of nucleophiles, negatively charged species OH minus, OCH3 minus, and also Lewis basis. So the difference between electrophile and nucleophile is electrophile is electron deficient, nucleophile is electron rich. Electrophile is usually positively charged, nucleophile usually negative charged. Electrophile possesses an empty orbital to receive the electron pair from the nucleophile. Nucleophile possesses unshared pair of electrons which are not firmly held to the nucleus. Electrophiles attack on electron rich center, nucleophile attack on electron deficient center. The difference between electrophile and nucleophile you can refer in your textbook and you can learn. Nucleophile means nucleus seeking. Electrophile means electron seeking. Nucleophiles have unshared pair of electrons which they can easily donate to electrophiles. Electrophiles have reactive sites with only 6 valency electrons. They can accept electron pair from a nucleophile. So, one atom is there means the atom will have the electrophilic center. In an alkyl halide, due to polarity of carbon and halogen bond, a partial positive charge is generated on the carbon atom and hence the carbon atom becomes electrophilic center.